This is a lesson for Algebra 3 out of the pre-calculus book on 9.6 on the fundamental counting principle and permutations and combinations. Now, all three of these, the fundamental counting principle, permutations, and combinations, are all ways to find out the number of ways you can do something. All right, this is kind of a lead into probability, because when you're doing probability, you're always finding out how many ways can you do this out of the total ways it's possible. That's probability. Well, so today we're going to work on how do you find that total ways possible to do something. So let's start off our fundamental counting principle. Okay, if you can take this back to what you did probably in middle school, you would make a tree diagram. And in this tree diagram, you'd say, oh, I have a red shirt, and I have a blue shirt, and I have a green shirt. And for each one of those shirts, I have either khakis or jeans that I could wear with each one of those shirts. And with each one of those, then, I have flip-flops or tennis shoes or Vans or whatever. Okay, and so I would have that for each one of these. Now, this is what you did in middle school. We're not going to do this, but the idea is that this will list out all the possible ways that you could have this outfit created. What we're really looking in is finding the total number of outfits. And really, if you count this, there'd be 1, 2, 3, 4, 5, 6. And it's basically this end branches of your tree diagram. Well, basically, though, in the end, if I had 3 shirts, let's say, and I had 2 pairs of pants, and then it looked like I had 3 different kinds of shoes, all I really do is take 3 times 2 times 3, and that's going to get me my total number of outfits. So in this case, it would end up being 3 times 2 is 6, times 3 is, I'd have 18 outfits. So the fundamental counting principle, all you're doing is taking all the number of ways you can do this times the number of ways you could do this, and that could actually keep going. You might have numerous numbers that you're multiplying together there, but you just multiply those options. Okay, so let's look at an example. Oh, and one of the things we have to remember when we're doing fundamental counting principle is that, and this will change, but on the fundamental counting principle, the order is important, and you are allowed to do repeating. So let's do some examples. For instance, if you look at phone numbers, the order that you pick the numbers for your phone number is important, because if you switch 2 numbers around, all of a sudden it's someone else's phone number. So the order that you list those numbers is important. You're also allowed to repeat. You can use 2 4s in your phone number. That doesn't matter. So that's why we're going to use fundamental counting principle. This right here will change as we try different methods. Okay, so if you think about it, how many possible phone numbers are there? Well, phone number is 7 digits. All right, and I could have 10 possible digits for the first number, and I could have 10 for the second because I'm allowed to repeat. I could have 10 for the third. Remember, it's actually 0 through 9. That's why it's a 10 possibilities, not 9 possibilities. And because I can repeat, I'm just going to sit here and I would have 10 possibilities over and over and over. So if you just multiply those all together to do your fundamental counting principle, well, you're really just going to end up with 1, 2, 3, 4, 5, 6, 7 zeros there. So you're looking at, got my commas messed up there, but 10 million different phone numbers. Now, really that's the number of ways that you can rearrange numbers in 7 digits. But there are certainly restrictions when you start talking about phone numbers. Now, as soon as you start doing these restrictions, you have to kind of tweak your fundamental counting principle. Here's an example where it says the first number cannot be a 0 or a 1. Okay, so now when you're looking at your possibilities, your first one can't be a 0 or 1, so now we're down to only 8 possibilities for that first digit. Okay, now the second digit, they don't have any restrictions for, and since I can do repeating, it would be 10 possibilities. and then again 10, and again 10, because I can repeat. And so my 10 million different phone numbers just turned into 8 million different phone numbers. All right. Okay, let's try another exception. It says the first three numbers can't be a 911 or a 411 or a 211. Well, 911 obviously, 411 is information. I think 211 is like a volunteer hotline kind of thing. And really it's anything 11 they have reserved for special uses. So 511 doesn't work, 611 doesn't work. Okay, so the question is, of my 8 million phone numbers that I have here, how many of those actually start off 911 or 411 or 211? Well, let's think through this. It's going to have to be some number, and really, since it's 911 or 411 or 211, it can kind of be anything, except that I've restricted it still that it can't be a 0 or 1. So I still have 8 options for that first number. All right, for the second number. Now remember, I'm trying to force these situations to happen. So the second number looks like it has to be a 1. So I would only have one possibility. It's got to be a 1. And the third number. Well, in these examples, we're trying to force this to happen, and in all of them, the third number is a 1. So I would only have one option. It's got to be 1. And then I would be back to my 4 numbers after that, and there's no restrictions for that. This could be anything, this one could be anything, this one could be anything, and this one could be anything. And so when we look at how many phone numbers are there of the 8 million that go 911 or 411 or 211, well, there actually are, if I multiply these all together, remember, 80,000 phone numbers that are 911 or 411 or 611 or whatever. And so instead of 8 million possibilities, now I've got to subtract out these 80,000 numbers that aren't going to work. Okay, so those are just some kind of things you have to start thinking about when we start putting some restrictions. We have to tweak these numbers in the fundamental counting principle. Okay, let's try one more example of this with license plates. Okay, so when I was little, we used to have license plates that had a letter, and then it had a number, and another number, and another number, another number, and another number. That was the license plate. Okay, and just as a little side note, this letter right here was always the first letter of your last name. The numbers varied. Okay, so if that's the case, how many possible license plates were there when I was a little girl? Well, assuming there's no restrictions at this point, so the first character had to be a letter, so I would have 26 possibilities for that. Now, the next one would have to be a number, and so that could be any number, no restrictions there, so there'd be 10 possibilities there. And the third one has to be a number, and in license plates you can repeat, so you could use the same letter more than once. And so basically then I'm going to run out of room here, but you're going to have, that's a 10. So 26, 1, 2, 3, 4, 5. All right, so we've got 2,600,000 license plates. But here's the reality. You know, back in the day, before I was little, families only had one car. There was one car. Dad drove it to work, Mom stayed at home, and nobody went anywhere. Okay, so when I was growing up, we had a couple vehicles, and as my brothers got older, we even had a third vehicle. And so and if you think about it, probably if we surveyed in our class, I bet you it's pretty common to have 3 or 4 vehicles per family. So not only is population going up, families are getting more license plates, so they had to change it. So now what they do is letter, 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 number, number, number. And in all actuality, it wasn't just letter, 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 number, number, number. I kind of almost feel like it started that way, but then they switched it also. It can go number, 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 letter, letter, letter. You might go look at your license plate. See, does it have letters first or numbers first? I feel like this is more common, but whatever. Okay, so let's look at all the possibilities we'd have here. You'd have 26 times 26 times 26, because you can repeat, times 10 times 10 times 10. Or you could go 10 times 10 times 10 times 26 times 26 times 26. Okay, well, you're going to get the same thing either way. So if you find out what this equals and then just double it, you'll get the number of license plates that are available now. And it's more like 35 million or something like that instead of 2 million. So there are a lot more license plates available than there used to be. Now, part of that is, well, the reason for it is because we're using more letters than we used to. The more letters, the more options. If you go to California or New York or somewhere, you'll see license plates that have a lot of letters and not very many numbers. Or maybe there's no pattern to it, but that's the way they work that. All right, so let's say this is 35 million. You have the exact answer in your notes. You can multiply that out. Okay. Just like with the phone numbers, there's restrictions. There are restrictions with license plates too. There are some, like for instance, you're not going to get a license plate that says angle side side 1 2 3. They're not going to have those, pass those out. Okay, and so any of these naughty 3-letter words aren't going to be put on license plates. So our 35 million is going to drop by all the different license plates that do that. So let's think about this for a second. How many license plates are angle side side? Something, something, something. So here we go. There's 6 letters, or I'm sorry, 3 letters, 3 numbers. So how many options are there for this first character? Now remember, we're trying to force this to happen and saying, well, how many of these are going to do this? Well, I'd only have one option. It has to be an A. And I'd only have one option here. It has to be an S. And I only have one option here. It has to be S. That's going to force it to be angle side side. But then, now I wrote 1 2 3, but it could be 4 7 9 or something else. It doesn't really matter what the letters are. I'd still have 10 options for the first one, and they're allowed to repeat, so there'd be 10 more, and then 10 more. And so that basically ends up being 1,000 different license plates that start off angle side side. And actually, they're not going to let you go 1 2 3 angle side side, so if you did the reverse of it, that wouldn't work either, so that'd be another 1,000. So that's 2,000 license plates that have ASS in them that they can't use. And really, so we have to take 2,000 off of our 35 million here. But it's not just that 3-letter word. There's lots of 3-letter words, and there's just different restrictions out there that they don't allow license plates to have. So for every one of those naughty words, you're going to subtract 2,000 off of this 35 million. Okay, so I really like the fundamental counting principle because it lets you do these special restrictions, and you just kind of think through it step by step. It's not a formula that's you're forced to use the same thing every time. You can tweak this to do what you need it to do.